Hello, this is Alex.
And Mohamad.
We are here today to discuss Circuits Lab number 2.
Yup.
We decided to do a video lab report because we wanted to show off our creativity.
Typically, every week, as part of the lab experiment, students have to design their own projects. Here's an example of one of our talented students.
The goal of this week's lab experiment was to study the different techniques of electrical measurements, such as frequency of a certain noise. To achieve this goal, we used an oscilloscope in order to measure the different frequencies produced by sound waves. The oscilloscope maps the noises using a scale of time versus voltage amplitude. From this time-voltage relationship, a frequency, or pitch, can be measured. For our lab's design part this week, Dr. Erickson challenged us to create a project that involves a combination of music or sound, and it must involve analysis of waveforms captured using the oscilloscope.
However, we are not versed in any musical instrument, so we chose to compare the frequencies of animal noises to that of imitated ones by humans, i.e. our own imitations of these animal noises, and this is how we accomplished it.
We began our design project by selecting 4 different animals: dog, cow, sheep, and wolf. The audio files of the noises of these animals were found online. We aimed to see how well us humans can imitate the animal noises by measuring and comparing the difference in frequencies between animal recordings and corresponding human imitations.
Here's an image of our lab setup. A computer, an oscilloscope, a speaker, an amplifier, and a microphone were used for the purpose of this experiment. The current setup was used to perform the experiment for recording the frequencies of the animal noises found online. First, several audio clips for each animal were analyzed in order to choose the easiest to imitate. Then, we measured the frequencies of each animal using an oscilloscope to capture the waveform of each animal's sound clip. The oscilloscope was connected to one of the computer's audio jacks, while an amplifier was connected to another audio jack of the same computer. We were able to hear the animal noises through the amplified speakers: barks, moos, mees, and woo, as the oscilloscope tracked the waveform each animal noise made. The voltage scale used on the oscilloscope was 200 millivolts, and the time scale used was 2.5 milliseconds. The stop button on the oscilloscope was used to freeze the oscilloscope screen on each individual animal bark, moo, meh, or whoo, in order to measure the waveform's frequencies.
After measuring the frequencies of the animal noises, we went on to imitate the 4 animals. A microphone was used to translate the human imitations into recordable frequencies. The oscilloscope was once again used to measure the frequency of each imitated bark, moo, bah, and howl. In the setup, the microphone was connected directly to the oscilloscope without the use of the computer this time. And again, the stop feature on the oscilloscope was used to freeze the screen on each imitation's waveform in order to measure the frequencies. A dog was imitated first, followed by a cow, then a sheep, and then a wolf. So, Mohamad imitated the noises of a dog and a wolf.
And Alex had the privilege of imitating a cow and a sheep for the sake of this experiment. Here's a video showing us in action.
Alright. Alright, you do the cow now, come on. No, you need to stop this one, so stop.
You just started up. I'm trying to hear it, just to listen to it.
Alright, cow, let's go. Cow, mate. 265.
Prior to the experiment, it was predicted that the frequencies of both the animal noises and the human imitations would be relatively similar, in a range of plus minus 200 Hz.
We had 2 independent variables for this study: animal type and human imitation of animal type, myself versus Mohamad. Our dependent variable was measured frequency, and our constant was the volume from the computer at which each animal sound clip was analyzed.
Following the procedure precisely, 4 frequency readings were taken from each animal clip, as well as each corresponding human imitation. These frequencies were placed in Table 1. An average frequency for each animal clip and human imitation was calculated in Microsoft Excel. The average frequency was calculated in order to reduce the differences between each measured frequency trial.
You can see here that Figure 1 displays the 4 measured frequencies of each animal from the online audio clips. Most of the measured frequencies were in a range of about 800 to 1600 Hz. Here in Figure 2, we can see the 4 measured frequencies for the animal imitations done by Alex, cow and sheep, and then Mohamad, dog and wolf. Unlike in Figure 1, the imitations had a larger range of frequency from about 200 to 1200 Hz.
This figure compares the average frequencies of each animal clip to its corresponding human imitation. From this figure, the dog and wolf were within the hypothesized 200 Hz range of difference. However, the cow and sheep were not. The cow clip and imitation had the largest difference range of about 1200 Hz, and the sheep clip and imitation had difference range of about 300 Hz.
Unfortunately, the hypothesis for this experiment was not upheld. Only 2 out of the 4 animal noises analyzed had human imitations that were within a 200 Hz difference in average frequency. But we were able to see a trend between all animal sounds. The animal sound clips online had a much smaller range of frequency than that of the human imitations. The larger frequency difference in the human imitations may have been affected by the use of 2 different people for animal sound imitation. Mohamad is obviously better than I am at imitating animal sounds, based on the measured average frequency between the dog and the wolf. Like in all experiments, there were sources of error, and our experiment was not perfect. We had a difficult time stopping the oscilloscope screen at the precise moment of optimal frequency. The human thumb and reaction time is relative to each person, therefore it was not a precise measurement every time the oscilloscope screen was stopped. Volume of the human imitation was observed during testing to affect the frequency amplitude reading on the oscilloscope. As I increased in volume during the cow and sheep imitations, frequency seemed to spike higher relative to a lower volume imitation. The large difference between the cow and sheep imitations and the corresponding sound clips can be attributed to this volume effect. On the other hand, the sound clips were played through the computer at a constant volume. Both Mohamad and I imitated 2 animals apiece. This non-uniform imitation may have affected the results of the experiment. Though Mohamad and I are both male, we most likely have different pitches and frequencies in our voices.
What was learned from this experiment that frequency of certain noises and musical notes can be measured using an oscilloscope. The oscilloscope graphs a waveform mapping voltage amplitude of each note or noise over a certain amount of time. Frequency of noises can be affected by factors such as volume of the noise being analyzed, as well as what pitch of voice is producing the sound. Myself and Alex have different pitches in our spoken voice, and it can be inferred that each individual animal, no matter if it is the same animal, has a different pitch in their voice. Depending on the person, humans can imitate the frequency of different animal noises. Thank you for joining us. Have a good day.